Hello, welcome to our talk addressing advanced use cases with new cloud functions capabilities. I'm Vinod, I'm a product manager at Google.
Hi, I'm Sarah, and I'm a cloud developer advocate at Google.
Here's the overview of our talk. First, we'll provide you a product overview on cloud functions, then walk you through key FaaS and function as a service use cases, then walk you through the FaaS programming model. Then we'll cover key performance, scalability, and availability features in cloud functions. Then walk you through key new security features in cloud functions, as well as cover the cloud event support that is being added to cloud functions as well. And to conclude, we'll cover a couple of exciting demos provided to you by Sara. So let's get started. Cloud Functions. Cloud Functions is Google Cloud's event-driven serverless compute platform. Cloud Functions let you write small snippets of code that react to events such as HTTP, as well as asynchronous events. For example, uploading a file to a cloud storage bucket and doing some processing after that, or sending a message to PubSub and processing the message accordingly. Cloud functions are truly serverless. They scale seamlessly. You don't have to manage any of the infrastructure and you pay for what you use. Further, functions have a streamlined development model where you can get started very quickly and have it running as well. In addition, functions are integrated with different GCP products through events as well as HTTP. Key fast use cases that customers and users use cloud functions are serverless webhooks. For example, doing a GitHub push commit, and then processing a function and posting a message to Slack. Real-time data processing, where you can upload files to a cloud storage bucket and process the data using ML APIs and store the result back. IoT backends, where temperature and humidity sensors from all over the world upload temperature and humidity data that is processed by cloud functions, and you take corrective action accordingly. Intelligent applications such as Twilio chatbots that upload messages to cloud functions, which are processed by a natural language API or BigQuery for trend analysis. Functions in the FaaS programming model are very easily deployable. You can deploy a function from the UI, from the CLI, through the IDE using functions frameworks, as well as the API. Here's a simple example where you have a snippet of code which can be deployed using a single command ready to serve traffic in minutes. And you can deploy these functions in your favorite programming language. We are super excited to ship these languages to you. Think about Node, Python, Go, Java, .NET, Ruby, and PHP. Along with the programming model, functions offer key performance, scalability, and availability capabilities. We are super excited to ship the min instances capability in cloud functions. Cold starts is a real problem in serverless where whenever your function starts up or your serverless service starts up, you have a startup tax. Min instances lets you mitigate this problem, which are pre-warmed instances. So for example, in this podcast transcription application, you can have a set of pre-warmed instances with each of your functions in order to improve end-to-end latency of your serverless workload. Here is a GitHub tutorial as well. Please feel free to check it out. Longer processing. We're super excited to ship longer processing with cloud functions. Now you can process your functions up to 60 minutes. This capability is in preview. This is 6x the execution time. Think about longer data processing pipelines and longer ML pipelines. Along with longer processing, we're also shipping larger instances with cloud functions. Now you can have up to 16 GB of memory, which is in preview, as well as the ability to have multiple CPUs. So think about larger in-memory operations, as well as like embarrassingly parallel applications with your functions. We've also expanded the number of regions that are available with cloud functions, going to about 22 regions globally. Along with the other capabilities that we talked about, we're adding some new security capabilities in cloud functions. We are super excited to ship the integration with Secrets Manager for your cloud functions. Now you can, securely set your environment variables and access them using Secret Manager in your cloud functions in a programmatic fashion and making the developer experience seamless as well. Along with secrets, we are also shipping a capability called customer managed encryption keys. So users can provide user provided encryption keys, which can then be used by GCP to do all the encryption throughout the function flow. This gives more control to the users and greater level of encryption as well. And if the key does not work, Google cannot even access the data and it's completely in the control of the user. Shared VPC support. We're also super excited to ship this new networking capability, which lets your functions access resources in a shared VPC. You can access compute engine resources as well as on-prem systems. Further, this is within a secure VPC SE perimeter, which is a logical boundary that adds additional restrictions, such as only authorized users can deploy a cloud function within the perimeter, as well as only authorized users within the perimeter can invoke a function. Further, the function can be configured behind a cloud load balancer for load balancing as well. In addition to the networking capabilities, we're also shipping a capability called private pools that gives users more control on their build time environment for their cloud function. Users can have more control on how their cloud function is built, thereby letting users control the entire software supply chain of code, build, and invocations or run. Along with the security capabilities, we are adding cloud event support to cloud functions as well. Cloud events are industry standard events which are open and portable, making your architecture for the long term as well. We are adding cloud event support for cloud functions by supporting cloud audit logs. This lets you invoke functions from over 90 plus GCP products. For example, every time you create a compute engine or a VM instance, you can now invoke a function to do some processing after the VM creation, such as labeling the VM. Every time a BigQuery job finishes, you can do some processing after the job is completed. The same applies for SQL, spanners, so on and so forth. Now, I would like to hand over to Sara, who has a couple of interesting and exciting demos for you on these capabilities.
Thanks, Vinod. In the first demo, you'll see how you can use Mint instances to keep a certain number of your applications warm to improve performance time and minimize cold starts. And the reason why you might want to do this is if, for example, you know you're going to be receiving additional traffic soon. Perhaps it's due to like a Black Friday, Cyber Monday event, or you know that you need to get the best possible latency time. So by keeping a certain number of instances warm, you can help reduce code starts and get the best latency and the response time possible. So you'll see how that works in this upcoming demo. In this first demo, I have a Node.js function, and it's already deployed with Mint instances set to 0, which is the default. So let's take a look at this function code. Now the entry point is hello world. So that means that all the code outside of the entry point is going to be in global scope. So in other words, here is the event handler, the entry point for the function. So any code outside of that function, like here, as you see, is in global scope. So this, so line 3, where we call the startup method. This is going to get executed anytime there is a cold start, like the instance is warming up. So we'll log that this is a cold start, and then you'll see me simulate a long connection. This could be something to a call to establishing a connection with the database. This could be an API call that takes a while to respond, but something that you want to do once, cache that value and have it available for future invocations of your function. And so once this timeout, the sleep, it comes back, then you'll see me log I'm ready now, and then return ready back. So here's the code that is invoked every time, that is executed every time the function is invoked. And I'm using utility for just pure debugging purposes, just to illustrate what is happening. And it's getting the current status of the promise. And if it's still a cold start, it reports that. It waits until the 30-second timeout has completed, and then says, now I'm warmed up using the warm emoji. Otherwise, if it's already a warm instance, then it just reports back that it's a warm instance. And of course, it needs to respond back to the request with request completed. So let's invoke our function and see this in action. So on the trigger, we'll see we click here, and this is going to take because of the 30 seconds. So we can go to cloud logging, and as that is spinning up, we'll see it report, as we saw in the code. I am a cold start. That will be logged first. Okay, so there it is. I'm a cold start. I'm still cold start. So if we go back here, we'll see I'm a cold start. And since we invoked it while it was still pending, that's where we see this. And then as soon as it comes back, it will say I'm warmed up. Okay, we see that the request completed, and we'll see in the logs. Okay, the function completed. So now I am warmed up, which is great. But let's say like we know in advance we're going to get future invocations. What can we do to, you might be thinking, what can I do to have this ready to go? Maybe this connection, database connection already established, or like this API call, like have that value already cached, ready to go when there is, when you can predict that you're going to have future invocations. And that's where min instances comes in. So now you'll see me redeploy the function using min instances. So let's go to edit. And then in these advanced features, scroll down, you'll see min instances. And instead of using 0, let's give it 5. And deploy that. Now that this function has been deployed with the new min instances, we can go here and see in details now that we have 5 min instances. We can confirm that if we go to the logs now and rerun this query, you'll see the cloud function is updated. And you might think that this is off by 1, but instead of 5 cold starts, because remember, we're spinning up 5 instances, you might be thinking, well, why am I seeing 6? Well, this first one is called a health check. This is just to make sure that your cloud function builds, and as a part of it, not being invoked, but just builds. And since this is in global scope, that's going to get executed. And but this is just a health check, just to make sure that like the coding, like there wasn't like a compile error or build error, or there was like a missing dependency, or like the function identity lacked permissions. That's what this health check is. So that's why you see 6 of these. And now if we were to go, we'll go back to the function, go back to trigger, and see, now you notice that it hit instantly. And if we go to cloud run, go run query, we really see that after like all the instances were warm, and you see I'm a warm instance. So as you just saw, you might want to consider using min instances to keep a certain number of your cloud functions instances warm in case you're expecting increase in traffic, or you just need to get the best latency times possible. Now, for the second demo, you're going to see how a cloud function can listen for and respond to a cloud audit log event. For example, let's say that a company has a policy where their engineers need to put their username as a label on any VM that they create. Well, you can have a checklist for their engineers to follow. but they might forget or they might have a typo. And so one of the best ways to reduce human error is to, quote, automate it out. So instead, you could write a cloud function to listen to a cloud audit log event for whenever a VM is created and have the cloud function automatically label the VM with their username instead. In this second demo, you'll see how you can use a cloud function to listen for and respond to a cloud audit log event. In this scenario, you'll see a cloud function automatically label a VM using the username of the person who created it. So first, let's go over how to deploy a function to respond to a cloud audit log event. Now notice in this deployment, you'll specify the trigger event filters. So we have of type cloud audit log, service name is compute, and insert instance is when a new instance is created. So let's deploy that. And while that deploys, let's take a look at the code. So the first thing to notice is that the signature for the function event handler is different, and now is cloud event. And so we grab the data from the cloud event data payload. And just in case an event has more than one audit log, we want to make sure we're responding to the very last event. The resource names, they look like this in this particular case, and so we want to break it up and grab the instance name and the username, and we log appropriately. Now, if you're trying to, like in this case, set a label, the API makes sure that you're setting the most recent label, and so you need to get the instance label fingerprint. Otherwise, you're not going to be able to set the label. And then we can invoke the set VM label. And then finally, we log the results. So let's look at the set VM label. It's the more interesting of the two. So here's the API call. We set up instance name, zone, project, resource. Here I have the label named as creator, and then you'll see my username for this account. And then we make the API call to set the label for the instance. Okay, now let's take a peek. And yes, our cloud function has finished deploying. So let's jump over to Cloud Console, and if we refresh, we'll see the VM label demo is up. So let's go to the VMs, create a new VM. And we'll just use the defaults. And as soon as that is created, you'll see the label is added. And the nice thing about having a cloud function automatically perform this task is one less thing that you have to ask your engineers or your developers or whoever is doing the particular task. It's one less thing for them to remember to do. So instead of having like a long checklist of like, did I do this, did I do that? The more you can automate that out, the less human error you'll have. So let's go to the instance. And now you can see that the creator is Duraf Aras, which is my username or my full name, Sara Ford, spelled backwards for my demo account purposes.
Thank you, Sara, for those amazing and exciting demos. So that's a wrap, folks, with our session on Cloud Functions. Please check out Cloud Functions at cloud.google.com/functions. Please also sign up for the advanced features that we have covered in this session. You can do so by reaching out to us. Further, if you have any questions, please feel free to reach out to us as well. Thank you, and have a great conference.